Hello my dear students. So today we will see a new chapter, the second chapter, that is motion in straight line. So let us begin with our class with motion in straight line. Okay, so let us see what is a motion in straight line. Motion in straight line is nothing but a one-dimensional motion or rectilinear motion. It is known as one-dimensional motion or rectilinear motion. Okay, so it has only either in a straight direction or up and down or forward and backward. So it has forward and backward motion, and up and down. Okay, so this is the basic information that you need for the motion in straight line. So here you can see the chapter motion in the straight line. Okay, so here there are frames of reference. So what is meant by frames of reference? It is nothing but there are two frames of reference. One is the inertial frame of reference and non-inertial frame of reference. Okay. Two frames of reference, that is inertial frame of reference and non-inertial frame of reference. Okay, there are two types of frames of reference: inertial frame of reference and non-inertial frame of reference. So inertial frame of reference is, I think you all know what is inertia. Inertia is nothing but which is constant or which is at rest or uniform motion. Okay, so the platform or the frame which is at rest or uniform motion. The earth is in uniform motion, so earth is a inertial frame of reference. It doesn't accelerate, right? And we can also say the building, it is not moving, that is a inertial frame of reference. The building doesn't move from one point to another point, so that is also a inertial frame of reference. The car which is at rest, that is a inertial frame of reference, but the car which is moving, that is a non-inertial frame of reference. Okay, so I will read out the definition. Coordinate system which is used to define the position, orientation and motion of the objects. So types of that is known as the frame of reference. So coordinates, it has x-axis, y-axis and z-axis. So wherever the particle is or the body is, we can define the position of that body with respect to the frame of reference. So there are two types of frame of reference: inertial frame of reference and non-inertial frame of reference. Inertial frame of reference is the frame either remains at rest or moving with constant velocity, and non-inertial frame of reference is the an accelerating frame of reference, okay, which is moving, always moving under different velocity. It has acceleration, so that is a non-inertial frame. So rest position, what is meant by rest position? If the object does not change its position, okay, so that is known as the rest, right? And the with respect to time also, the object which does not change the position, its position with respect to the surrounding over time, that is at rest. Then what is motion? Object changes its position with respect to the surrounding over time, that is known as the motion. So there are three types of motions. So mainly there are three types of motion: the translational motion, rotational motion, and oscillatory motion. So there are three types of motion. One is the translatory motion, rotatory motion, and oscillatory motion. So what is meant by translatory motion? So translatory motion is if this is a body, the body has so many particles in it. So if we apply some external force to the body, all the particles in the body will move in the same direction in which direction the force is applied, okay. So it will be moving in the direction of the force only. So that is known as translatory motion, okay. So what is the rotatory motion? So rotatory motion is nothing but the motion of a fan, for example. So this is a fan. Now this rod of the fan is known as axis of rotation. Axis of rotation. So now the axis of rotation, in this the particles will be moving in a fixed path. It has translatory motion, but the wings of this fan or blades of the fan, they will be having the circular motion. So that motion is known as the rotatory motion, okay. Oscillatory motion. Oscillatory motion is the motion of a simple pendulum, the motion of a swing, okay. So I think you have sat on the swing. So it makes to and fro motion, right, like this. So this is known as to and fro motion, that is known as the oscillatory motion. So this is a translatory motion, rotatory motion, and oscillatory motion, okay. So one by one we will see the definition. Translatory motion: all the points of the body moving uniformly in a single direction. Rectilinear motion along the straight line. Then curvilinear motion along the curved path. So that means all the particles will be having the same motion, move in the same direction. Rotational motion: when an object rotates about a fixed axis. So this is axis of rotation. Along with this, the other particles will be having a circular path or circular motion, that is known as the rotatory motion or rotational motion. Oscillatory: back and forth motion of an object about a mean position. So this person is sitting in the swing, so the swing is moving to and fro, forward and backward. So this type of motion is known as the oscillatory motion, okay. So now let us go to the position. So what is meant by position? Position is the location of an object at a given time, okay. Distance: total length of the path traveled by an object irrespective of its direction. It is a scalar quantity and the SI unit is meter. So distance is always greater than 0. Just it is the total distance traveled by the body. Displacement, it is the shortest distance between 2 points. So from here, from your home to school, how much will be the shortest distance? You can move from here also, from here, here, you can take so many directions of the home to school, but which is the shortest one? So that is known as the displacement. So displacement can be 0, it can be greater than 0, it can be lesser than 0. So it is the shortest distance traveled to between the 2 points. It is a vector quantity. Displacement can be greater than 0, less than 0, or equal to 0. Displacement is always less than or equal to the distance. Understood? I hope you have understood till here. So now let us see the speed. Speed is what? It is the distance traveled by time taken. Okay, so it doesn't have any direction, it is a scalar quantity, it has only the magnitude. So how much is the speed of that vehicle? With what speed the ball has come. Okay, so speed is simply how fast you are traveling. The rate at which an object's position changes, or the distance an object travels per unit time. Speed equal to distance by time. So speed is distance upon time. Okay, so it is a scalar quantity. Its SI unit is meter per second. Okay, right? So this is the speed. Average speed is the total distance traveled by the object in a particular time interval. Average speed is total distance traveled by total time taken. If a body covers equal distance in with distance different speed, then average equal to 2v1 v2 by v1 plus v2. So this is the average speed equation. V average equal to, it is denoted by v only, that is 2v1 v2. v1 is the initial speed and v2 is the final speed. v1 plus v2. Okay, and instantaneous velocity, it is defined as the rate of change of distance of an object over a very short time. V in INS equal to, INS is instantaneous, limit of delta t tends to 0, delta s upon delta t, which is equal to ds by dt. It is the average distance by time. Okay, so this is the general equation of the speed, and this is the average speed equation, and this is the instantaneous speed equation. Now let us see the velocity. What is velocity? Velocity is nothing but the velocity is displacement by time taken. It is also denoted by V, and its SI unit is also meter per second. Okay, so it can be 0, lesser than 0, or greater than 0. Okay, so this is the velocity. Again, in velocity we have instantaneous velocity, average velocity. So this is the general equation of the velocity. Instantaneous is again Vins equal to limit of delta t tends to 0 delta s by delta t ds by dt. Then average velocity is total displacement by total time. Then velocity is displacement by time. So hope you have understood the chapter till here, that is motion in straight line. So we'll continue in the next lecture about acceleration. Okay, till then take care, bye bye.